Okay, so may I write this in time delta t, small time t, the mass through area 1 delta m1 equals rho a delta v time. Actually, hold on. May I replace this? I'm just going to call it not delta v. I'm just going to call it v1 time delta t. Okay, how do I get that? Think of what this is. What should this be? All of it. Should that not be delta v? The volume?
No. Yeah.
Do you get it?
Yeah.
So then this volume will be A times delta X. Yes?
Yeah. Oh, I do.
See, this is a very scary looking equation that I just wrote. But you just broke it down and now it doesn't seem scary anymore. Right?
That's so confusing.
Oh, okay. So let's talk about this. So rho is what? M over V? Can I write this as delta M over delta V? Will this become delta V equals delta M?
Yes.
Is delta V for a pipe area of the thing times the length?
Okay.
So then may I write this as A dot dx?
Sure.
Is x the same as speed equals distance over time? So can I write v equals delta x over delta t? So may I write delta x as v delta t? Right? So every scary looking equation is actually fundamentally simple. We just have to find that simple thing that it began with. Isn't that beautiful? Does everybody get that, right? May I erase this now?
Don't, why would you?
No,
Just leave it. Just let it there. Yeah. Don't need a raise.
Oh, I was not planning on leaving it. Okay. Which means I just need to move it away.
It's fine.
No one objecting to me moving it away, right?
No.
Okay.
Just don't erase.
Don't erase it.
It's
It helps us
unnecessary to
remember
erase.
stuff.
Yeah, you
Okay.
can take away
I'm not taking it away. I'm okay with it. I was not planning on doing it, but that's okay. Okay, so does that mean that at A2 in the same time, may I write delta M2 will become rho A2 V2 delta T
Yes.
by the same logic? Should delta M1 be the same as delta M2?
Yeah.
Okay, so may I also then say, that was number one. I'm also going to ask you another question. If this goes from this height to this height, what is causing this change? We're on Earth. There we go. So that means gravity is playing its role in this case? So gravity should be doing some work on this situation? How much work does gravity do on it? All the work. Is that true? Is this the work that gravity does? Note, I need a delta here because that's the mass that's being transported. May I also write this as delta M is what will cross both H1 and H2? Yes?
Yes.
Okay. Number 3. What else will do work on this? Pressure. Okay, so what is work?
Yes.
So what is force? dx? What is this?
Volume.
Do you remember doing that in thermo?
Yeah.
And the only other difference is that we add a minus sign here. Why do we add a minus sign here? Because as pressure goes up, volume has to go down. So we add a minus sign. So the reasoning for the minus sign is as pressure goes up, V has to go down. And for those of you who are taking thermo next semester, remember that. We'll do this. No, next year.
Okay, that's cool.
And I will ask you guys at that point. And then we will derive it again. So then you'll remember. But see how everything is connected to everything else? Appreciate the fact that we do the same things over and over and over again. We don't do anything new. Okay, so that means I can rewrite this work as, okay, ready for it? It's gonna look scary. Stare at it for a second. Oh, I should call it work done by pressure. That looks scary, right?
Little.
Break it down. What is this?
It's just a lot of times there's some.
And then what is that? It's not scary. It just looks scary. It's not.
Both those V's are for volume. Those are lost. Those three values together make your deviation. I love that V is V for.
I know. But you have to know which V. But this is not scary anymore, right? It looks scary, but it's not. It's quite simple. Good? Now comes my favorite law.
In all of physics.
In all of physics.
That'd be.
This is the most fundamental law in the world. Delta E equals 0. Or delta E equals work done by a non-conservative force. So what's a non-conservative force in this case?
Friction.
Which I can call it work done by pressure. Pressure increases eta, which increases friction. Okay, so may I write WP equals kinetic energy plus potential energy. Then may I write P1, A1, V1, delta T minus P2, A2, V2, delta T, 1/2 delta M V2 squared minus 1/2 delta M V1 squared plus delta M G may I divide the entire problem with delta M, the entire equation by delta M. You guys should do this in another step. But I am allowed to cheat. Will I be left with P1, A1, V1, delta T divided by rho A1, V1, delta T? May I write delta M as that?
Yeah. I don't like it. Yeah.
No, you're gonna like it. It's gonna be more fun. Can I do that?
Yeah.
Yes. Okay. So may I also write this as P2, A2, V2, delta T divided by rho A2, V2, delta T. Same logic?
Yeah.
So this is 1/2 V2 squared minus 1/2 V1 squared plus G, H2 minus H1.
Yep.
Will these go away?
Mhm.
What am I left with? It's so pretty.
Because it's purple.
That could be true, but
Could be.
equation is so pretty. Do you want to know what it means?
Yes.
May I write this side? So everything in here is pretty much constant, right? At point 1 and at point 2. Do you want to know what Bernoulli's equation looks like? That is what Bernoulli is known for. So,